Welcome to our short lesson on partitions. Unfortunately, partitions are not something that are mentioned at all in our book, but we're looking at points that divide a line segment into portions. We are familiar with midpoint, which would divide a line segment in half. Now we'll be looking at things that divide it into other sections. And we'll go through this, but we're going to have a formula where the x value is equal to x1 plus our ratio, which will be k. In midpoint, it would have been a half, of x2 minus x1. And our k value of the point we're looking for, sorry, not our k value, our y value of the point, y1 plus k times y2 minus y1. So as we use this formula, we'll talk about what it means so you always aren't all like, oh my goodness, I have a new formula. Let's look at a sample problem. Find the point M that divides the segment AB into a ratio of 2 to 3 if A is at 0,15 and B is at 20, 0. So we're not actually going to, this is not going to be a straight line from straight horizontal line. But let me just picture that. AB is at one end of a line segment that's at 0,15. And B, the other end of a line segment, that's at 20, 0. So we could picture this if we wanted to. A would be at, B is at 20, 0. A is at 0,15, and the line segment is going down. Now, when we say the ratio 2 to 3, 2 plus 3 is a total of 5. So if we were to be able to break this into 5 equal segments, we would want the point here that it's 2 units, 2 sections, from A to this point M, and then 3 sections from M to B. So as we said in the formula, we're going to find an x value and a y value. So the x value is the x coordinate of our point M. And that x value is going to be basically, we're going to take our starting x value, which is 0, and to that, we want to add a point that is 2/5 of the total distance of the x value, which is 20 minus 0. So if you remember, our formula for x was the x value is x1, which in this case, our 0 is x1, plus our k value, which is our change, which is 2/5, because 2 plus 3 is 5, over our x2 value, 20 minus 0. And actually, I was rewriting the formula, so I should have. In this type of problem, what you pick as x2 and what you pick as x1 actually makes a difference because you want the distance to be 2/5 from A, not 2/5 from B. So now we're actually going to do some solving. Plus 2/5, 20 minus 0 is 20. So 2/5 of 20, 2 times 20 is 40 divided by 5. 40 fifths. 40 divided by 5 is 8. So if x equals 0 plus 8, x is 8. So our x, I'm going to put it here, our x coordinate for point M is 8. So 8, so like along here somewhere. Now we're going to use the same type of formula for our y value. So our y value, which is the y coordinate of point M, is going to be equal to our y1, where we started, plus the ratio, the k value, which is 2/5 of the way, of the distance from 0 minus 15. Okay? So y equals 15 plus 2/5 of negative 15. You're going to see that that negative actually is going to make a difference in a minute. So y equals 15. 2 times 15 is negative 30. By 5 is negative 6. So 15 plus negative 6 is the same as 15 minus 6. And y then equals 9. So our point M that divides this segment AB into a ratio of 2/3 is 8, 9. So let's say it would be like right there. We're going to be at a point now that if we divided this total length into 5 segments, this would be 2 of those segments away from A, 3 of them away from B. So we're going to try this again. Find the point M that divides segment AB into a ratio of 5/3 if A is at -4, -2, and B is at 4, -10. So remember, first we're going to do X is equal to where we start at plus the ratio K2 minus X2 minus X1. So our X value for this point in the middle is going to be equal to where we're starting at on X, -4, plus the K value. Now this is not 5/3, this is 5 out of 8. We want 5 spaces, 1, 2, 3, 4, 5. Here, another 3. So we're dividing this segment into 8 segments. So we would write the K ratio is 5/8 of the distance from 4 minus -4. So X is equal to -4 plus 5/8. 4 plus 4 is 8. So X equals -4 plus 5 times 8 is 40, divided by 8 is 5. So X value is +1. I'm going to put that over here so I remember. Now, I'm going to use this same formula, but instead of X, I'm going to solve for Y. Once again, I'm actually finding the Y coordinate of this point M. So I'm starting at -2 plus 5/8 X2 minus X1. So Y equals -2 plus 5/8 of -10 minus -2 is the same as adding 2's, -8. So Y equals -2 plus 5 times -8 is -40, divided by 8 is -5. And Y equals -2 plus -5 is -7. So the answer is 1, -7. If I drew a line from -4, -2 to 4, -10, divided into 8 equal segments, and found a point that had 5 of those segments closer to A and 3 of those segments closer to B, that point would be 1, -7. I want to find the point N that is 5/6 of the distance from A at -7, 2 to B at -1, -4. So for this one, our K ratio is 5/6. We're first going to find our x value for this point M. So we're going to start at x1, which is -7, and we're going to add 5/6 of the total distance on x from A to B. So x2, -1 minus -7. So x equals -7 plus 5/6, -1 plus 7 is 6. So that becomes x equals -7 plus 5 times 6 is 30, divided by 6 takes me back to 5. So x equals -2. That's the x value for this point M. Now we're going to find the y value for this point M. So the y value is going to equal y1, which is 2, plus 5/6 of y2 minus y1. So y is going to equal 2 plus 5/6, -4 minus 2 is -6. And 5 times -6 is -30. -30 divided by 6 is -5. So y is now going to equal to 2 minus 5. So y is -3. So the answer is -2, -3. That's going to be the point on a line that I can draw from -7, 2 to -1, -4. That is 5/6 of the distance starting on A and going to B. Problem, we're given something a little different because we are given the point M is at 512, which is located on a line segment AB. Point A is an endpoint at 0.22 and point B is the other endpoint at 11.0. At what ratio does point M divide the line? So in this case, we don't have the K value. That's what we're trying to find. But unlike the other problems, we do have the X value and the Y value of the point along the segment. So we can still use our formula, plugging in our X values and solving for K. So X1 is 0 plus x2, which is 11 minus 0. And we're solving here for k. So 5 is going to equal 11 times k, because 11 minus 0 is 11. That's 11k plus 0 is 11k. So k is going to equal 5/11. So 5/11, remember to write that as a ratio. It's 5/11ths of the way, but that means there's 5 basically to one side of the point and 6 to the other. Now, if we did this correctly, we actually only need to do this one time for the x value. The y value, the ratios when we do the y value need to be the same. So let's check it. Our point that we're finding for is 12. Has a y value of 12 somewhere on this line. y1 is 22 plus k value and then 0 minus 22. So I get 12 equals 22 minus 22k. So 12 minus 22 is going to be equal -10 equals -22k. When I divide, the negatives cancel out. I get 10 over 22, which simplifies, they're both divisible by 2, to 5/11ths. So it's 5/11ths of the way. We were asked for the ratio. The ratio is written as 5:6. You are given point M at -7, -2, which is on the line segment AB, with endpoints of A at -9, 2, and B at -2, -12. What is the ratio? So M, the x value of point M, sits at -7. In order to find the ratio, we're going to solve for K. So -9 is the starting value, plus K, which is the ratio, -2 minus -9. So -7 equals -9 plus K. -2 plus 9 is 7. So I'm going to add 9 to both sides, and I'm going to get 2 equals 7K. K equals 2/7. That means the ratio is 2 to 5. This point M is 2/7 of the way between closer to A. To make sure I did that right, I'm going to go ahead and check the y values. Should have the same ratio. So the y coordinate for M is -2 equals my y value of the closer endpoint is 2 plus the K value, and then y2 of -12 minus 2. So -2 equals 2 plus K times -14. When I subtract 2, I get -4 equals -14K. When I divide by 14, the negatives cancel out. And when I divide both of these in simplest form, I get 2/7. So once again, that breaks it into a ratio of 2 to 5. I hope that this video has helped you understand partitions.